Hello students, we are live now. Hello students, we are live now. Good morning, Abhinandan, Matthew. Good morning. Janvi has also joined. Who is One Tap Gamers? Saida Hasiba, good morning. Navya has joined. Okay. Okay, let's start today's class. So today trigonometrical identities I am going to do as per your request. You wanted to do this chapter. So let's start with the chapter. So by the time others are joining, we'll just discuss the formulas we are going to learn, the formulas which we are going to use in this chapter. Okay, so let's start. Is my audio and video clear? Is my audio and video clear so that I can go ahead with the class? Okay, thanks for confirming. Let's start. See, first of all, in trigonometrical identities, most of the questions which we are going to do are proof type questions. Okay, for that we need to know some of the identities. So identities are, so some type of relations are there. So relations which are there, first of all, are reciprocal relations. Reciprocal relations. Before that, I'll just tell you, and you might be aware that we have 6 trigonometric ratios. So ratios are sine, cos, tan. So in short, I'm writing. So sine is SINE. So in short, SIN mostly we write. Then cos, cosine, tan is tangent. Then cosecant, secant, and cotangent. So these are 6 trigonometric ratios, and there some different type of relations are there. So first one is reciprocal relation. See, reciprocal relation, sine is related with cosecant. So sine theta is equals to 1 by cosecant theta, and also both it works other way also. You can also write that cosecant theta is equals to 1 by sine theta. So both ways it works. So both of them are reciprocal of each other. Then cosine theta is, it's a reciprocal of secant. So 1 by secant theta, and if you have to write in terms of secant theta, that is 1 by cos theta. Then third one is cot theta. It is equals to 1 by tan theta, and tan theta, if we have to write, it is equals to 1 by cot theta. So cot is cotangent. So how to remember, because so many relations are there, you just remember this way that SC mainly you have to remember always sine, cos and tan. Sine, cos and tan. See, remember this way that S is related with C. So maybe you will not forget S. So SC, when short form or mnemonic you can remember. So S is associated with C. Here also you can see S and C, they are related, and here also C and S, they are related. So this is just a way of learning. I am telling you, if you can remember, without this it's good. Now in reciprocal relation itself, fourth relation we have, so that is only for tan and cot. So tan theta, it can also be expressed in form of sine and cos. So tan theta is equals to sine theta by cos theta. And cot theta, since it's a reciprocal of tan, it can be expressed as cos theta by sin theta. So these relations are known as reciprocal relations. So these are very useful when we are doing the questions. So you can make a note of the relations, and somewhere notes you can make, or as of now if you want you can take a screenshot of this one. Okay, so let's do second type of relation. So second type of relations which we have is square relations. Square relations. So square relations are three relations. First one is sine square theta plus cos square theta is equals to 1. Here sine and cos are related. Sine and cos are related with each other. Then 1 plus tan square theta, it is equals to secant square theta. And 1 plus cot square theta, 1 plus cot square theta is equals to cosecant square theta. So only three are there because you can see they are in equation form. So equations can be changed also. Like this one, I'll just give you example with first one. So but we will be using as they are required in the question. Like the first one can also be used as sine square theta is equals to, suppose cos will shift to other side. So it will become 1 minus cos square theta. So like this we can use it in different way also, but these three forms which I have written here, so these things you can just remember. Okay, so these remember, then afterwards if you know these three forms anyway you can use according to the question. Yes, it is ICSE board. Then square relations we have done. Afterwards the last one which relations we have to learn is complementary angles relations. Complementary angles. Although many times we don't have to use these relations, but still you should know. So complementary relations also three are there. Sine complementary angles means when you add the angles. Like suppose if you are adding two angles A plus B, their sum is equals to 90 degree. So those angles whose sum adds up to 90 degree are known as complementary angles. So relation is sine 90 minus theta is equals to cos theta, or it works other way also. Cos 90 minus theta is equals to sin theta. So both ways it works. Then see these sin and cos is related. Here secant and cosecant is related. Like secant 90 minus theta is equals to cosecant theta. And then cosecant 90 minus theta is equals to secant theta. So third one is cot 90 minus theta is equals to tan theta. Or you can also express it in other way, tan 90 minus theta is equals to cot theta. So these were the relations which you have to remember. So relations only I have mentioned here. Till now we haven't started with the question. These relations you have to by heart the relations I can see, but once you just do practice, the relations will, you will not forget the relations, like you will become used to of these relations. Now before starting, see, other than that these two were trigonometric relations. So other than trigonometric relations, which I feel algebraic identities also you should know. So algebraic identities also I'll tell you before starting the question, so that when we have to use them, you should already be aware of them, that these were the identities. So I'm just going to start with the, now I'm just going to mention here some of the algebraic identities. Identities you are already aware, just a recap I am going to do. So what are algebraic identities? So, but what are algebraic identities? Is cos theta is equals to cos theta by sin theta. Yes, cot theta can be expressed in reciprocal relation. Cot theta, I have already explained, it can be expressed in sin and cos, which is equals to cos theta by sin theta. So algebraic identities I'll just mention here, then I'll start solving questions. So first one is a plus b whole square. A plus b whole square is a square plus b square plus 2ab. You can also write it as a square plus 2ab plus b square. Both the forms are same. You will be getting the same answer only. Then a minus b whole square. A minus b whole square is a square plus b square minus 2ab. Then we have a square minus b square. So this is equals to a plus b into a minus b. Other than that, other than these three, the identities which we might have to use are cubic identities. Those are a plus b whole cube. This is equals to a cube plus b cube plus 3a square b plus 3ab square. Then fifth one is a minus b whole cube. This is a cube minus b cube minus 3a square b plus 3ab square. The sixth one is a cube plus b cube. This is equals to a plus b into a square plus b square minus ab. Then seventh one we have a cube minus b cube. A cube minus b cube is equals to a minus b into a square plus b square plus ab. So these are very important identities. Many times in the questions of trigonometric identities, we might have to use these identities. Okay, so let's start now questions. Only identities we have discussed till now, nothing I have discussed. So let's start with the first questions, and the questions which I am going to do in this class also, the questions are from previous year papers. So all the questions have come in ICSE board exam class 10. So only those questions I have selected. So let's start. So in proof type of question, what we have to do, basically we have to prove left hand side. So you can see equation is there. So this equality sign is there. So left hand side we have to prove equals to right hand side. So we will start with one of the side. So most of the questions I will start with left hand side and prove, work out left hand side, and the answer should be equals to right hand side. So that's what we have to do. Anyone, any doubt till here, you can just comment. So left hand side of this question is 1 minus cos square theta by 1 plus sin theta. So this thing we have to simplify and it should become equals to sin theta. See, for some 6 rules I have like devised so that you can solve these questions in a good way, like some hints you might get. So what are those rules? Those rules also I'll tell you at the starting itself. So rules, first of all, if you see fraction, you can take LCM. Then second rule is that if any identity is applicable. So identity means like now trigonometrical identities, 3 types of relations we have learned. So any relation is applicable that you can apply. Third one is if any algebraic identity is applicable that you can apply. So fourth thing is you can also do this question. If any common factor is there, you can take out the common factor out. The fifth one is you can also rationalize it. Some questions where we have to rationalize the terms. So LCM, relations, algebraic, common factor and rationalization we have to do. So let's start now. So left hand side I have already written. So here you can see, first of all I told you, if any time you see fraction, if any time fraction is there, so the first thing that should come to your mind is taking LCM. So what is the first thing that should come to your mind is taking LCM. LCM means basically here what we are going to do, we will make denominator same. So here 1 was written like this only. So I just wrote it as 1 by 1 so that you can visualize that this is also a fraction. How to take LCM? See, denominator you multiply with denominator. So what we will get if we multiply denominator with denominator? So 1 into anything if we multiply. 1 into 1 plus sine theta. So it will be equals to 1 plus sine theta. And here you do cross multiplication. This you multiply with this and this, that we can write as the first term of the numerator. Again with 1 if I multiply, so 1 plus sine theta only it will come. Now minus. Now again here cross multiplication we will do. So again with 1 if I multiply cos square, so it will be cos square theta. Now I have taken LCM. So basically I have multiplied denominator, so that's how I got 1 plus sine theta, and then cross multiplication with this one I multiplied 1 plus sine theta, so that's how I got first term of the numerator. Then minus sign as it is, then with 1 we have multiplied cos square theta. So now what we can do, first step is done. Now we have to see is there any relation which we can apply, and also you have to keep on looking at the right hand side. So relation, see here one square is there. See square you can see, so that is again giving us a hint that we can apply square relations. So square relation of cos I have discussed with you. We know sine square theta plus cos square theta. Yes, so square relation we can apply. Sine square theta plus cos square theta is equals to 1. But here what do I have? Here I have cos square theta. Okay, in this question. So that means I need the value of cos square theta. So sine I will shift to other side. So what will be the value of cos square theta? Cos square theta is equals to 1 minus sine square theta. So that's what we will substitute here. Like this we have to use square relation. Remaining things as it is I will write. So 1 plus sine theta. This minus sign as it is, because minus is there, so let's write other terms in bracket. So I will get 1 minus sine theta, sine square theta, inside brackets I am writing 1 plus sine theta as it is. See, because minus multiplication will take place, so after minus if two terms are there, make sure you are writing those terms in bracket. Now 1 plus sine theta, 1 plus sine theta minus, let's open the bracket, minus 1, and whenever minus is outside the bracket, because of minus multiplication inner signs will get changed. So this minus will change to plus, as minus into minus is plus. So this will become plus sine square theta by 1 plus sine theta. Now this 1 and this 1 will get cancelled. So what is left behind? Sine theta minus sine theta plus sine square theta by 1 plus sine theta. Now as per the rules which I have told you, the same rules we have to use here. So only 5 rules which I have told, like taking up the common factor, algebraic identities and relations, LCM. So out of those 5 rules, again see here two terms are there, sine is present in first term and sine is present in second term also. So then what we can do, here as sine is present in both of the terms, so we can take common factors. So this is how you have to recognize, in both of the terms sine is present. So when sine I am taking common, so how I will write? First of all, we know sine theta is sine theta only. Sine square theta is sine theta into sine theta. Then 1 plus sine theta as it is, denominator I am writing. Now when I am taking common factor, see this is common factor, sine is common. So common factor I am going to write outside. And now what is left behind? First term nothing is there, that means 1 we will write. When nothing is there, we have to write 1. And here from second term, 1 sine we have taken out. 1 is left behind, so we will write 1 plus sine theta. By denominator is 1 plus sine theta. Now denominator is 1 plus sine theta and numerator both the terms in multiplicatory form. Sine theta into 1 plus sine theta. So sine theta into 1 plus sine theta, it will get cancelled and we are left with only sine theta, which is equals to our right hand side also. Hence proved. Yes, so take common sign. Okay, good. So is this question clear to everyone? Is it clear? Shall we do next question? If anyone has any doubt, you can tell me. So some of you are giving your suggestions. Yes, Jayashri has given the suggestion. Even Anika, good. This you can give me the suggestion like what we can do. That's how the live class should be. Okay, let's do next question now without wasting any time. So this is the question. Left hand side I will write. If any question, any doubt is there, you can just post in the comment section. I'll just go through. After completing each and every question, I'll read what is the doubt, what are the doubts, and then I'll take the doubts also. So left hand side is equals to, I'll just rewrite it. It is secant theta minus tan theta, it's x, plus 1 by secant x plus tan x. And what we have to prove it? We have to prove this expression equals to 2 by cos x. 2 by cos x. So this is what we have to do. So let's start. See, first of all, the same thing like I have told you, if you see fraction. So here also fractions are there, two fractions are getting added. If two fractions are getting added, so the very first thing that should come to your mind is taking LCM. Yes, so take common a square minus b square. Yes, we will get a square minus b square after taking LCM. Always remember, whenever two fractions are there, we have to make the denominator same by taking LCM. So how to take LCM of these type of expression? Multiply denominators with each other. So first of all, denominator I am going to multiply. So it is secant x minus tan x into secant x plus tan x. Now numerator will multiply this first, cross multiplication we will do. So if with 1 we multiply secant x plus tan x, we will get same. Now this plus as it is we will write. Now this term also we will multiply, cross multiply. So this is how we will get the terms of our numerator. So cross multiplication will get, so this is secant x minus tan x, because with 1 if we multiply anything, the answer will be same. Yes. Now like terms we can simplify. At numerator, whatever like terms are there, that we can simplify. So plus tan and negative tan, it will get cancelled, because same term minus same term, it is always 0. So tan minus tan is 0. So I am going to cancel it. This is 1 secant x, this is 1 secant x. So 1 plus 1 is 2. So here we will get 2 secant x by, now denominator what we will get? See, this is a minus b into a plus b, like I have told you from those 5 rules only which I have told you. So here algebraic identity we will use in denominator. So what is the identity? Identity is a square minus b square, because it is, we have got this form a minus b into a plus b. A minus b into a plus b is a square minus b square. So here you can see two brackets are there, a minus b into a plus b. So a is secant x and b is tan x. So this will become, so this form is already given to us and we will write it in a square minus b square form. So which will become a square, which is secant x square, minus b square, which is tan square x. Now again, so which relation we can apply? So till here we have done with step by step. If fraction is there, we can take LCM. After taking LCM, we have to see any relations. If trigonometric relations we cannot apply, then we have to look for algebraic identity. So here we can apply a square minus b square. So that's what we have done. Now after this, again we have to see it at each and every step. First of all, we have to keep on checking if we can apply any trigonometric relation. Yes, so secant square x minus tan square x is equals to 1. So we can apply here square relation. We have learned square relation, 1 plus tan square theta is equals to secant square x. This is what we have learnt while giving introduction. I have given you this. So here if tan we shift to other side. So I'll get 1 is equals to secant square x minus tan square x. So this relationship we are just using it differently. Tan we are shifting to other side, it will become minus tan, and this is same the term which I have at denominator. Secant square minus tan square, this is equals to 1. So this will become 2 secant x by 1. Now by 1, if you want, it's not required to be written. You can only write it as 2 secant x. 1 is not at all required. Now see, left hand side is 2 by cos x. Now we know, till here we have done, we know secant and cos, they are related by, yes, so they are related by reciprocal relation. So we know 2 as it is, I'll write. So secant, we have learned at the starting reciprocal relation. So secant is equals to 1 by cos x. So here 2 can be written as 2 by 1. So when I multiply 2 into 1 is 2. 1 into cos x is cos x, and this is equals to the right hand side of the given identity. So hence proved. Yes, you people are giving me suggestions what can be done, and the suggestions are very correct, whatever we have to do. So Jayashri, Hasiba, Janvi, good. So after doing reciprocal relation, we have got the right hand side of the equation. Okay, let's do next question now. So next question you can see on my screen. We have to use left hand side of the equation. So left hand side is what? Left hand side is cos A by 1 plus sin A. Cos A by 1 plus sin A plus tan A. So this is left hand side. So first of all, again if you see left hand side, you can take 2 fractions are there. But before that, one rule which I didn't tell you, 6 rules I have told. Okay, 6 rules. First of all, LCM I have told you. Then trigonometric relations I have told you. Then algebraic identities I have told. Then taking out the common factor. And rationalization I have mentioned. 1, 2, 3, 4, 5. A 6th rule you can write, changing everything to sine or cos. So these 6 rules you can always remember, only 6. So changing everything to sine or cos if it is possible, that also we can do. So here in this question we can do that. So this is cos A by 1 plus sin A. Cos A by 1 plus sin A plus tan. So how we can change tan? Yes, so tan can be changed to sine and cos, like as per the rule I have told you. So we can change it. So it is equals to sine A by cos A. At the starting of the video I told you this reciprocal relation. So tan is equals to sine A by cos A. Now this rule we have applied. Now again 2 fractions are there. If 2 fractions are there, so 2 fractions they are getting added. So that means we have to take their LCM. So what will be the LCM? Same way this rule I have told you LCM how to do. Multiply the denominators. So this what we will get, 1 plus sine theta, 1 plus sine A is there, 1 plus sine A into cos A. Now here the terms which we have to write at the numerator, that will get cross multiplied. So cos into cos, it will become cos square A. Cos A into cos A is cos square A plus sine A into 1 plus sine A. See, till previous question only 1 was there at the numerator. So same terms we were writing, because with 1 if you multiply anything the answer will be same. Here but at numerator some different terms are there, so we have to actually multiply them. So cos into cos is cos square plus sine into 1 plus sine A. I have just written like this because when bracket multiplication will do with both the numbers with both the terms I have to multiply. So cos square as it is I will write cos square A plus sine A into 1. Sine A into 1 is sine A plus this plus as it is we will write, only bracket multiplication we are doing. So it will become sine square A. What it will become? Sine A into sine A is sine square A. Now denominator, let it be like this only, 1 plus sine A by cos A. Now again, if any relation can be applied, yes, so sine square A plus cos square A. So one relation we have learnt, square relation, because whenever you see square, just think about the square relation. So here square we can see, first relation itself we have done, sine square A plus cos square A is equals to 1. So we can write them together. I can write it as cos square A plus sine square A. Only interchanging of the terms we can do, and sine we can write at the end, sine A. So in denominator what I'll get? 1 plus sine A by cos A. Cos A. Now this cos square A plus sine square A. See here, sine square A plus cos square A is equals to 1. See, sine square A plus cos square A, or if I write it cos square A plus sine square A, both the things are same. So this will become equals to 1. 1 plus sine A by 1 plus sine A into cos A. See, 1 plus sine A, it's getting multiplied. So up and down we can do cancellation. So what is left now? 1 by cos A. After doing cancellation, we are left with 1 by cos A. So 1 by cos A, again we have to see, we have to look at what is there at right hand side. So right hand side secant A is there. And we know 1 by cos A is equals to secant A. It's a reciprocal relation. At the starting of the question, I have explained you. Yes, so yes, Janvi has given, even Navya and Jayashri. Okay, good. So till here, anyone, any doubt? So step by step if we do, see only these 6 things which I have told you, you can make a note while doing question, that these 6 things you can focus. So accordingly, whatever is required, we can apply. The questions are not very difficult. Let's do next question if you don't have any doubt. If you have any doubt, you can just let me know. I'll explain the doubt. Okay, no doubts, that means. Now, left hand side, I have to use. See, basically you have seen till now in each and every question I have used left hand side, but if you want you can go ahead with the right hand side also. Right hand side you can work out and prove that answer equals to left hand side. See, both ways you can do. It is not a mandatory thing that you have to only go with left hand side. Now I am used to of using left hand side, so that's why I'm always using left hand side. But if you want to try things in a different way, you can also use right hand side and then prove right hand side equals to left hand side. That also is possible. Yes, so rationalization we have to do under root 1 minus cos A by 1 plus cos A. See, whenever you see these type of expressions, first of all, square root whenever you see. In square root type of question, most of the time rationalization we have to do. So this is confirm. Or sometimes maybe if you see these type 1 plus something or plus or minus expressions, if you see that time also you can do rationalization. Okay, so wherever it's possible you can do. But now I am just writing square root 1 minus cos A by 1 plus cos A. See, in questions of trigonometry, rationalization can be done with numerator as well as with denominator. Like mostly in 9th class when we learned rationalization, only we used to do rationalization of the denominator. But in trigonometry, any rationalization we can do, either it can be numerator as well as denominator. So you have to decide at the starting of the question whose rationalization you have to do. So here you see right hand side. If you see right hand side, whichever term is smaller. So smaller term, if you see in terms of terms, so lesser terms are there in numerator. Numerator only one term is there, denominator two are there. So the expression, either numerator or denominator, whichever has lesser number of terms, so that rationalization you have to do. Here numerator has only one term and denominator has two terms. So lesser number of terms numerator has. So that's why rationalization of numerator we will do. Now, what is the meaning of rationalization? Same expression but with opposite sign. So numerator has minus sign, so that means rationalization factor will have plus sign. I am doing rationalization of numerator. So 1 plus cos A by 1 plus cos A, same expression we have to write at numerator as well as denominator. Now next what we will get, see when you multiply same into same. See first of all here A minus B, here we will get identities. If you see the numerator expression, it is 1 minus cos A into 1 plus cos A. So it is this form now. Rationalization whenever you are doing, you will always get this form, A minus B into A plus B. So this identity we have to use here. Identity is A square minus B square. This form you will see, you have to write it in this form. So we can write that. So here A is 1, B is cos A. You have to figure out what is A and what is B. A is 1, B is cos A. So it will become 1 square minus cos square A. Because A minus B into A plus B is A square minus B square. A is 1, B is cos. So 1 square minus cos square A. Now if you look at the denominator, see denominator same term is getting multiplied with itself. So here don't do any multiplication. When we multiply same term with itself, like A into A, when we multiply it will become A square. So we will write it in square form. Any term when we multiply it with itself, we can write it in square form. So this will become 1 plus cos A whole square. Because 1 plus cos A into 1 plus cos A, we have got 1 plus cos A's whole square. Yes. So A square plus B square plus 2AB we are not going to use here, Janvi, because it will complicate the things. So that's what we are not going to do. We will use square relations. We will use square relations. Before that, let's simplify this thing. So 1 square is 1. Cos square as it is, I'll write 1 minus cos square A by 1 plus cos A whole square. Now 1 minus cos square A, this is again square relation we will use. See in first square relation we know sine square theta or A angle we can write. Still like this we cannot cancel. So most of the students, they will do this mistake. This square and this root they will cancel. This square we cannot cancel like this. Whole square should be there. If we have whole square only then we can cancel. So this 1 minus cos square, I am just using the square relation which is sine square A plus cos square A. So see here 1 minus cos square, that means I need 1 minus cos square. So that's why cos square, let's shift to other side. It will become 1 minus cos square A. Now 1 minus cos square A is equals to sine square A. So this numerator I am just replacing it with sine square A. And denominator I have 1 plus cos A whole square. Now what we can do here, see both the terms as whole square. So I will just write it as sine A by 1 plus cos A whole square, because numerator as well as denominator now whole square is there. So instead of writing whole square two times, I'll just write it one single time. So this square and root will get cancelled, because root means power 1 by 2. So that's why square and square root will always get cancelled. So what is left behind? Sine A by 1 plus cos A, and which is equals to our right hand side also. Yes, so sine square by 1 plus. So is this question clear? Is this question clear? Yes, cancel square and square root. Janvi, Siba and Jayashri has given the answers. Good. Shall we do next question now? Okay, let's do. Anyone, any doubt till now? Anyone, any doubt? Are you solving the questions along with me? Okay, let's do next question then. Left hand side I am just going to write. So left hand side is what? Left hand side is no doubts. Okay. So left hand side is tan square by secant theta minus 1. Okay, shall we do this question by using right hand side? See, although both the sides we can do. So let's try this question by using right hand side. Shall we do? Shall we do this question using right hand side? Or same way we should proceed? Okay, let's see. But you have to give me suggestions of what can be done. So right hand side, I'm just going to do, see, I just want to show you both the sides we can use. So right hand side is 1 plus cos theta by 1 minus cos theta. So if these terms are like this, 1 plus cos theta and 1, the terms are like the terms we had in previous question. So whenever I told you these type of terms are there, this can be solved by doing rationalization. So that you have to always remember. So these type of terms can be worked out by doing rationalization. So rationalization, now again you have to decide rationalization of numerator or denominator I should do. That I want you to tell me. Yes, so rationalization we can do. But should we do rationalization of numerator or denominator? Whose rationalization I can do? Rationalize the numerator. Yes, because again I have told you rationalization you have to figure out by this other side's terms you have to count. Numerator has one term, denominator has two terms. The smaller one, the lesser terms are with numerator, so that means rationalization of numerator we can do. So numerator's rationalizing factor. What is the rationalizing factor of numerator? Same term with opposite sign. So this is positive, so this will be negative. So 1 minus cos theta by 1 minus cos theta. Same term but numerator is opposite sign. So here plus was there. So here I have written minus sign. Now numerator I will get a plus b into a minus b. So a plus b into a minus b, again we have to use here identity. A square minus b square is a plus b into a minus b. So always whenever we are doing rationalization, so a square minus b square we have to use there wherever we are doing rationalization. Here we have done rationalization of numerator. So that's why at numerator we will apply identity. So A is 1, B is cos. So it will become 1 square minus cos square theta. 1 minus cos into 1 minus cos, like previous question we have done, it will become whole square. So same term, like again I'll tell you, if you multiply x with x, so it will become x square. So same term, when you are multiplying with itself, it will become square of itself. Now at numerator again, because now in many questions we have used, so it will become 1 minus cos square theta, because 1 the square is 1 by 1 minus cos theta whole square. Now we can see here square is there, again square relation we can apply. So directly here I am going to do, because 1 square cos square now I have used in so many questions. So directly we know now that 1 minus cos square is equals to sin square theta. If you use square relation here, so 1 minus cos, because we know sin square plus cos square theta is equals to 1. So if we shift cos square to other side, so sin square theta is equals to 1 minus cos square theta. So in many questions we have used the relation directly also, now you can write. So here in denominator I will be writing 1 minus cos theta whole square. So till here we have got, it is exactly same to the questions we have in the previous question also. Only thing was that there we had square root. But now we don't have any square root. We just have to see the left hand side. See, we should convert this into tan and secant. So what we can do? Yes, what should be done next? The left hand side of this one is in terms of tan square, where it's almost same, but we need the expression, the trigonometric ratios are different. Here we need tan and here we need cos. Here we need secant. So what can be done now? See, basically what can be done? Reciprocal relations we can. So because we have to think about the relations. So reciprocal relations we can see everything is in sine and cos. So let's convert it into tan and secant. So sine square, how we can convert? Because tan is what? Little bit we have to say sine by cos. So I will just, here sine is there. So sine square I already have. Sine square theta. So what I will do in the numerator part, I'll take cos as common. So cos as common factor, I'll take it out. When cos I'm taking it out, it will be in its whole square form. Okay, so it will be in whole square form. So then it will become here 1 by cos minus 1. Common factor whenever you are taking. See, whenever you are taking common factor, you can write this cos out. So when again if you multiply, here whole square is there. See, after multiplying you will get to know. I'll just show you if I multiply this with this. If I multiply here, because square is there, so cos, if I multiply cos theta into 1 by cos theta, what I'll get? I'll get 1 minus, here cos only will come. So it will become the same expression as it was earlier. So what I have done, I have just taken cos common. Is this step clear how I have taken cos common? So common factor whenever you are taking, so the numbers which the expression here, trigonometric ratio, we have taken out. So here you can just write this 1 by cos, and here we know because we have taken it out, so here it will be 1 only, because if you are taking it out nothing will be there. If nothing is there, so that means 1 you have to write. Is this step clear? Now this thing, sine square by cos square, this will become, and why square has come? Because whole square was there. So that's why when cos you are taking common, it will be in square form. So sine square by cos square, it will become tan square, and here also 1 by cos will become secant theta minus 1 as it is. So we will get, and which is equals to our left hand side also. So is this question clear? Let's do next question. Yes, so secant is equals to 1 by cos. So that's what we have changed. Now let's do next question. So next question you can see on my screen. Left hand side I am going to, because here right hand side is very small. So let's work out the left hand side here. So left hand side is sine A by 1 plus cos A plus 1 plus cos A by sine A. So this is left hand side. So how we can start this one? Left hand side we have to start. So rules I have told. Yes, so take LCM, because two fractions are there. If two fractions are getting added, so same thing should come into your mind, that to take LCM. So that is always this step only you have to do whenever fractions are getting added. So how to take their LCM? So LCM means denominators we will multiply. So denominators of this one, when we are multiplying, it will be 1 plus cos A, 1 plus cos A into sine A. Now here cross multiplication we have to do. So sine A into sine A will become sine square A plus 1 plus cos A into 1 plus cos A. It will become 1 plus cos A's whole square. So LCM how to take? First of all, denominators will get multiplied with each other. You can see. So I have written 1 plus cos A into sin A. Here cross multiplication we will do. So that's how we will get the terms of numerator. So sin A into sin A is sin square A. This plus as it is, and 1 plus cos A into 1 plus cos A, it will become 1 plus cos A whole square. So now 2 cosec A we need. So what can be done now? After taking LCM, this step what we can do? So you have to focus on the 6 rules I have told you. LCM we have utilized. Now any relation, is any relation applicable here? See, LCM I have told you, then trigonometric relations you can just see if they are applicable. Then algebraic identities you have to see if they are applicable. Rationalization we can do, taking out the common factor, and conversion of everything into sine or cos. So these are the rules I have told you. So as per the rules, what we should do now? First LCM we have utilized. So this thing we have done. See here, any trigonometrical relation is not there. So square relation directly we cannot apply. Or can we apply? Because it is not at all possible. Can we apply square relation? Okay, sine square is there. Okay, let's apply square relation because one of the student has told square relation. So I'll go ahead with that only. So square relation at this place only. Square relation at this place only we can apply because this is only whole square. So we know square relation sine square A plus cos square A. This is equals to 1. So here sine square I have. So this cos if I shift to other side. So sine square A is equals to 1 minus cos square A. So 1 minus cos square I can write it place of this one. 1 minus cos square A plus, let's write it this way. So I can write 1 plus cos A whole square. Now in denominator what is there? 1 plus cos A into sin A. Now next what we can do? So what should be the next step which we can do? So I have used now square relations. So which relations now we can do? So sine square A plus cos square A. Okay, so expansion we will not do. See right hand side, if you are seeing right hand side is very small term. If we do expansion here, A square plus B square plus 2A, it will complicate the thing. So what we will do? We will factorize it. So how to factorize? See here I have A square minus B square. So A square minus B square, I can write it in the form of A plus B into A minus B. So A square minus B square I can write as A plus B into A minus B. Then here also 1 plus cos A whole square I have. So instead of taking like applying expansion here, what we can do? This also I can factorize it. I can write it as 1 plus cos A into 1 plus cos A. Now here 1 plus cos A as it is by sin A. Yes, so take common. Yes, common we can take. So 1 plus cos A we can take common factor because in two terms, both of the terms 1 plus cos A is present. So common factor we can take. So 1 plus cos A is a common factor. So here what is left behind? In first term the leftovers are 1 minus cos A. This plus as it is we can write, and here I have left 1 plus cos A. So the terms which are left, that we can write. Now this is 1 plus cos A into sin A. Now the terms are in their multiplicatory form. So 1 plus cos A and 1 plus cos A will get cancelled. So if 1 plus cos A and 1 plus cos A is getting cancelled, so what is left now? Here numerator, if you simplify, cos A and cos A will get cancelled because negative cos A and positive cos A will get cancelled. So here 1 plus 1. 1 plus 1 is equals to 2, and in denominator we have sine A. So 2 by sine A I have got now. So we have got 2 by sine A. See, 2 by sine A means 2 into 1 by sine A, and 1 by sine A, if we apply reciprocal relation, it will become 2 by cosecant A. 2 into cosecant A, because 1 by sine is cosecant A. So is this question clear? Is this question clear? So, okay, see, from starting I cannot explain because so many questions I have explained till now. If you want once the video, because the lesson will get recorded, now you can continue from this session itself, this question itself. Okay, so we have got is equals to right hand side of the equation. Shall we do next question now? Shall we do next question? See, next question, again left hand side I am going to utilize here. So like I told you, both the sides we can see. So left hand side is sine A by 1 plus cos A. So sine A by 1 plus cos A. So how we should start? So how we should start this question? From 6 rules only you have to see what can be done, and you have to keep on looking at right hand side also. So how we can start this question? What can be done at the starting of this question? No comments? Okay, I'll just start then. So sine A, rationalize the denominator. So yes, we can do rationalize the denominator, because if you see, this is something like this 1 plus trigonometric ratio. So if this type of expression you see, you can rationalize the given expression. And here moreover, if you see right hand side numerator has two terms and denominator has only one term, that is 1. So that means we can rationalize the denominator here. So it will be sine A by 1 plus cos A. So rationalizing factor is 1 minus cos A, 1 minus cos A. Now this will get multiplied with this, numerator with numerator and denominator with denominator. So what we will get, sine A into 1 minus cos A. Now denominator, because we have rationalized, so this will always be A square minus B square. So whenever we are doing rationalization, that particular expression here, we have rationalized the denominator. So at denominator we have to apply that identity A square minus B square, because this is equals to A plus B into A minus B. Here we have already got this form, A plus B into A minus B. A is 1, B is cos. So that means it will become A square minus B square form. So A square means 1 square minus cos square A. So further we can write it as sine A into 1 minus cos A. Now this relation so many times we have used. See, 1 minus cos square A is equals to sine square A. 1 minus cos square A. Now in many questions we have utilized this one. So this is sine into 1 minus, so this square relation many questions we have used. So now I am directly utilizing this one. Now sine A into 1 minus cos A. So here I'll get sine square means sine A into sine A. Sine square means sine A into sine A. So sine and sine will get cancelled because they are in multiplicatory form. So sine and sine will get cancelled. So at numerator I am left with 1 minus cos A. So in denominator we have 1 sine. Now what we will do, we will write them separately. because we need cosec A minus cot A. So 1 by sin A, only separately I am writing, minus cos A by sin A. So 1 by sin A, now we know if we use the reciprocal relation, 1 by sin A is cosecant A minus cos A by sin A is cot A, and this is what our right hand side also. So I hope this question is clear. The questions are very easy. Yes. Cot is equals to cos by sin A, correct. Let's do next question because there are few questions which I have selected. I just want to finish those questions in this class. I hope you people are not tired. Are you all right? It's already 1 hour. Shall I do few more questions? Okay. So left hand side I am going to start with. Left hand side of this one is sin theta into tan theta. Sin theta into tan theta by 1 minus cos theta. Now right hand side also you have to see. See, right hand side is 1 plus secant theta. So accordingly we have to start working out here. So what we can do? How we can start this question? So how we can, not tired. Okay, good. We are good to go now. So how we can start this question? So sin theta. So what we can do? We have, see, 6 rules I have told you. So first one is taking LCM, which is not going to work here because fraction is only 1. If 2 fractions are there, we can apply that rule. Okay, change to sine and cos. Yes, so that rule we can apply, change to sine and cos, because we have 3 trigonometric ratios here, sine, cos and tan. But we know this thing, tan theta can be changed to sine and cos. As we know, tan theta is equals to sine theta by cos theta. So this change we can do. So this is also one of the rules which I have told you. So let me change this one. So what I'll get, sine theta into, at place of tan I can write sine theta by cos theta. So denominator I have 1 minus cos theta. Now see, when two fractions are getting divided, we can change it into multiplication. How? Because inner one will get multiplied and outer ones will get multiplied. So sine into sine, first of all it will become sine square theta by 1 into cos is cos theta. First fraction as it is we can write, then we have to write a sign of multiplication. So first one will get multiplied with the last one. Like you have to remember, outer ones will get multiplied and inner ones will get multiplied. So with sine square 1 will get multiplied, and with cos theta 1 minus cos theta will get multiplied. So what is now we are left with sine square theta. If you multiply sine square theta with 1, we'll get sine square theta, and here we will get cos theta into 1 minus cos theta. So next, like the same thing again we will use, because square relation is there. Yes, so I have already told 6 rules. You can just work on those rules, and these questions are not very tough. So sine square theta by cos square theta into 1 minus cos theta. See, sine square theta in many questions we have used. So square relation we can use. So sine square theta is equals to 1 minus cos square theta by cos theta by 1 cos theta into 1 minus cos theta. Now 1 minus sine square theta. See, sine square theta I have used to 1 minus cos square theta. Now this further can be factorized. Further it can be factorized as a square minus b square. It is a square minus b square. See, a square minus b square we can write it as a minus b into a plus b. A minus b into a plus b. Here I have cos theta and 1 minus cos theta. See, 1 minus cos theta and 1 minus cos theta will get cancelled. So what we are left with now? Here we are left with 1 plus cos theta by cos theta. So now separately, like we did in previous question, so 1 by cos theta plus cos theta by cos theta. See, 1 by cos theta is equals to secant theta. If we apply reciprocal relation, this is the secant theta. Cos theta and cos theta will get cancelled. So this will become secant theta plus 1, which is equals to right hand side also. And hence proved this question. Is this question clear? Shall we do next question? Shall we do next question? Okay, let's do next question. Yes, so what we can do in this question? Again, left hand side if we see, left hand side is 1 plus tan A whole square plus 1 minus tan A whole square. So what we can do in this one? So what can be done in this question? So this is very simple. Again, out of the 6 rules you have to tell me. First of all, LCM. LCM is not going to work here because fractions are not there. Then relation. So directly here trigonometrical relations we cannot apply. Then the next one is algebraic relations. So algebraic identities we can use here. So A plus B. Yes, so square relation we cannot apply like directly here because the square should be on the trigonometric ratio. We can use identity. So identity we can use. So identity, both the identities we can use. Here we have A plus B whole square and here I have A minus B whole square. So A plus B whole square is A square plus B square plus 2 into A into B. So this is for first one I have used. Then for second one, this is for first. Then second one, it is A minus B whole square. So A square plus B square. A square plus B square minus 2 into A into B. So A is 1, B is here. If you want, you can write also A is 1, B is tan A here. So we can just expand now accordingly and we'll open the bracket. So 1 square is 1. Tan square as it is I'll write, so 1 plus tan square A, 2 into 1 is 2 into tan A is 2 tan A plus 1 square is 1 plus tan square A minus 2 tan A. So I've just opened the brackets here. So plus 2 tan A and minus 2 tan A will get cancelled. So here now 1 plus 1 like terms we can add. 1 plus 1 is equals to 2. Tan square, see this is 1 tan square, this is also 1 tan square. So 1 tan square plus 1 tan square, it will become 2 tan square A. Now common factor we can take, see this is 2 here also 2. In both the terms 2 is a common factor. So common factor we can take it out. So here nothing is there, that means 1 we can write 1 plus tan square A. Now which relation we can apply? Now which relation we can apply here? Here we can apply now square relation, yes. So secant square is equals to 1 plus tan square A. So here this 1 plus tan square A, I have told you the square relations. So this will become secant square A. So we will get 2 secant square A which is equals to our right hand side also. Yes. So this is also right hand side we already got. Now let's do the next question now. Anyone, any doubt till here? So next question I am going to do, see 2 more questions are there. I'll just complete the questions. If anyone has any doubt, you can just post in the chat. I will take your doubts. 3 more questions I'll finish and I'll give you then practice questions. So left hand side of this one I am going to write. So sine theta minus 2 sine theta by 2 cos cube theta. See here, there is a cube will come. So there is a, so sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta. So what can we do? What can be done in this question? See, 6 rules I have told you. In these 6 rules we can apply taking out the common factor. So sin is present in both the terms of the numerator and cos is present in both the terms of denominator. So that means we can take out the common factor. See, sin, if I take out common from numerator, so what will be left behind? 1 minus, see here first term full sign is taken, so that means if sign we have taken, nothing is there, so 1 we can write, minus as it is, so 2 as it is. So from cube, see sine cube means sine into sine square, so 1 sine we have taken out, so that means sine square is left behind. By now here in denominator we can take cos common, so cos theta I am taking out common, so here same way 2 cos square theta is there, then minus 1, same way like we have done in numerator, denominator also same thing we are doing. Now see, this sin theta by cos theta, this is equals to tan theta, reciprocal relation we have already learnt. Now square relations we can apply, because this term basically we want to cancel, then only see we will get our answer. 1 minus 2 into, say sine square, in many questions we have used sine square is equals to 1 minus cos square theta. So square relation I am applying. Why I am writing it directly? Because now in so many questions we have used this relation, so that's why directly I am writing. So denominator is 2 cos square theta minus 1. Now tan theta as it is, let's open the bracket here. So 1 minus 2, and this we have to multiply, bracket multiplication has to be done. So minus 2 into 1 is minus 2, minus, see minus is outside the bracket, so minus into minus will be changed to plus 2 cos square theta by 2 cos square theta minus 1. Now let's simplify like terms here. So tan theta will come as it is, 1 minus 2, 1 minus 2, see plus minus is minus, so 2 minus 1 is 1, but with minus sign, because with greater number negative sign is there. So minus 1 plus 2 cos square theta by 2 cos square theta minus 1. See, these two terms are same, 2 cos square theta minus 1, this is also 2 cos square theta minus 1. So these two things will get cancelled. So we will get our answer equals to tan theta, and this is equals to right hand side also. Now let's do next question. Only 2 more questions I'll do. So let's finish the questions fast. So here LCM we will take, because 2 fractions are there. If 2 fractions are there, so we can take LCM. That's the first rule I have told you. So here LCM will be the multiplication of the denominators. So it will be secant A minus 1 into secant A plus 1. Now this cross multiplication we will do. So cross multiplication when I will do, it will become secant A into secant A plus 1, then plus secant A into secant A minus 1. So I have just taken LCM. After taking LCM, in denominator we can see, in denominator we can apply identity A plus B into A minus B. So always whenever you see A plus B into A minus B, we can apply identity A square minus B square. So but what we can do at the numerator? So numerator, first of all, again secant we can take out common, because it's present in both the terms. So I'm just taking it common. Secant A is common. Remaining things whatever is left, like that only we will write. So this is secant A plus 1. This plus sign as it is. Secant A minus 1. Secant A minus 1. So remaining things I have written. Then here we will apply identity A square minus B square. A is secant A, B is 1. So a minus b into a plus b is a square minus b square. Let's simplify this. Here inside the bracket plus 1 and minus 1 will get cancelled. So basically we are left with secant plus secant. So secant plus secant will become 2 secant. So 1 secant a is outside the bracket. Inside we will get 2 secant a. So secant a, so we have done one identity, square identity or square relation. You can say 1 plus tan square a is equals to secant square a. So now if I shift 1 to other side, it will become tan square a is equals to secant square a minus 1. So here I have got secant square a minus 1. So that means this is equals to tan square a. This is equals to tan square a. Now what we can do? We have simplified this thing. Here if you multiply this, so this will become secant a into secant a is secant square a. 2 as it is we will write. So secant square a by tan square a we have got. Let's change them to sine and cos, because left side we need cosecant a. So when I am changing it to sine and cos, so secant will become 1 by cos square a, because secant's reciprocal relation is cos. And tan is at the denominator. See, tan will become sine square a by cos square a. So cos square a will go on top because it is already there in denominator. So cos square a and cos square a will get cancelled. So we are left with 2 into 1 by sine square a. See, 1 by sine square a is equals to cos square a. So which is equals to right hand side also. Yes. So here we have completed this question also. So little fast I am doing because now I think you people are in the flow. So many identities we have used again and again. So I feel you are able to understand. Okay, let's do next one now. And this question is the last question of the class. So let's do this one now. See how we can start this one. 1 plus cot a minus cosecant a, 1 plus tan a plus secant a. So how we can do this question? We have to prove this question equals to 2. So what we can do here? We can just change everything to sine and cos. So what we can do here? Let's change everything to sine and cos. So first bracket if I change, so this will be 1 by 1. So let's write it in yes. So change to sine and cos. So cot can be changed to sine and cos. Cot is cos by sine a minus 1 by sine a. So relations now you are already aware with. So directly I am writing cot is cos a by sine a. Cosecant is 1 by sine a. So 1 plus tan is sine a by cos a. And secant is, this one also I can write 1 by 1. Secant is 1 by cos a. So reciprocal relations I have used here. Now what we can do inside the bracket, let's take LCM. So 2 brackets are there because 3 terms are there. 3 fractions are there in each of the brackets. So fractions when they are getting added or subtracted, we can take LCM. LCM basically means making denominator same. So first one we can multiply with sine, and here this first one we can multiply with cos, and denominator also up and down will multiply. So what we will get here? Here I will get 1. So here what we will get? Sine a plus cos a minus 1. So sine one single time I am writing, which sine is at denominator. Now here what we will get? Cos a plus sine a plus 1 by cos a. So this is what we have got. See this question, yes, LCM we have taken inside the bracket. Now there is a trick in this question, and what is that? See, if you see numerator, see sine plus cos. Here also sine plus cos, same term is there. So sine plus cos minus 1, here plus 1. So this thing can be written as this is of this form. Suppose this is some x, so this is, or a only you can write. So x minus 1, x plus 1. So this is of this form, a square minus b square. So a plus b into a minus b, where a is sine a plus cos a. So this is my a. So this is this form now, a minus b into a plus b, and a minus b into a plus b is a square minus b square. Here my a is sine a plus cos a, and b is equals to 1. So this type of question like this you have to do. So I will get a square minus b square by sine a cos a, as it is we can write. Sine a cos a, as it is we can write. Now here further what we can do, yes, a square minus b square we can do. So what should be the next step? Next step, again from the rules itself, like I have told you, here sine a plus cos a whole square is there. So what we can do, we can apply here whole square formula, a plus b whole square. So a plus b whole square is a square plus b square. A is sine, b is cos. So a square plus b square plus 2 into a into b minus 1 by sine a into cos a. Yes, so a minus b whole square we have applied now. So here again a square plus b square, which is sine square plus cos square. So sine square plus cos square we have already done. So sine square plus cos square's value is equals to 1. So here I am just going to substitute. This is equals to 1. So here sine square plus square relation we have already done. 1 plus 2 sine a into cos a minus 1 by sine a into cos a. See, 1 positive and 1 negative will get cancelled. So we are left with 2 sine a into cos a by sine a into cos a. So sine a cos a will get cancelled. So our answer is 2, which is equals to right hand side also. So here we have completed this question also, which was the last question of the class today. I hope you are able to complete all the questions and you have understood as well. See, here few practice questions are there. You can take a screenshot of these questions. Okay, Himanshu is telling me bye. Okay, you just take a screenshot of these questions. Try to do this question. See if anywhere anything you have missed. See, the recorded video of this class will be available on the channel. You can just go through it again and try to do the questions on your own. Okay, so I hope you have taken the screenshot, and thank you for watching this class today. See, if you have understood anything and if you have liked, please don't forget to like the video and subscribe the channel. Thank you so much for watching this.